Statisticians, they deal with large set of data. To interpret and analyze large set of data, you need to organize that data. In a classroom, teacher asks students about their favorite subject and she gets this answer. Here we have the raw data of students' favorite subjects. Can you tell which one is the most favorite subject in a classroom or the least favorite subject? Well, in this case, we have the data from 45 students. If you spend some time, you should be able to answer this question. But interpreting raw data is time consuming, and when you deal with large set of data, it becomes almost impossible to interpret raw data without organizing. Let's organize this data. Here we have a table. Left column shows subject name and right column shows number of students who liked this subject. There are 13 students who liked mathematics. There are 11 students who liked science. There are 9 students who liked history and 12 students who liked English. So, the most favorite subject in a classroom is mathematics and least favorite subject is history. Well, there are also fair number of students who liked English as well. Now, let's telemark these numbers. 13 is equal to 553. 11 is equal to 551. 9 is equal to 5 and 4 and 12 is equal to 552. Here 13, 11, 9 and 12 are the frequencies. Frequency tells number of times a particular observation occurs. Mathematics subject was liked by 13 students. Science subject was liked by 11 students. These numbers represents frequency. Now, in a same classroom, teacher conducts mathematics exam and here we have a score of mathematics out of 50 marks. Let's organize this data. The left column shows marks and right column shows number of students who have scored that marks. So here 2 students have scored 11 marks, 1 student has scored 18 marks, 3 students have scored 30 marks. Nobody has scored 50 out of 50, hence we have 0 here. If we put data in this way, does it help you understand how did the class do? Can you tell how many students have performed very well or how many students have performed poorly in the classroom? To answer these questions, to understand this data better, you need to group the data. Here, in this table, we have created groups for marks. These groups are called class interval. 0 to 10, 10 to 20, 20 to 30 and so on. First part is the lower limit of the class interval and second part is the upper limit of the class interval. Size of class interval is equal to upper limit minus lower limit. In this case, the size of classroom is 10. 10 minus 0 is equal to 10. When you group the data, it is important that you create a class interval of same size. Okay, so there are 2 students who have scored in this group. We have 6 students who have scored in this group. You may have noticed there is an overlap between intervals. Here we have 10 as an upper limit and here we have 10 as a lower limit. Let's say student scores exactly 10 marks. Which part of the group he will be in? He will be in this group. Data with a value of upper limit will not be a part of that group. Basically, data with lower limits are included and upper limits are excluded. Hence, if someone scores exactly 10 marks, he will be in this group. So, this is how the frequency distribution looks like for 45 students, and telemarks will look like this. Let's look into another example. Here we have heights of students in centimeters. Let's group the data. There are 4 students in class interval 100 and 110, 6 students in class interval 110 and 120. Most students' height lies in these 3 groups. We have few tall students as well. Did you notice any difference in dataset used in this example and dataset we saw in previous examples? Well, there are 2 types of data: discrete and continuous. Discrete means countable and continuous means measurable. These examples we saw earlier regarding students' marks or favorite subjects, those are discrete data. Data which are obtained from measurements are continuous data. In that data, there is some degree of approximation involved. Weight, height, speed, all these are example of continuous data. And grouping is very helpful to analyze continuous data. Okay, so in this video, we'll learn about organizing data. We also looked into how to group the data using class interval.